Alright, hi y'all. Today we're going to be going over vector analysis on the FE exam, and really I'm just going to try and get y'all introduced to one, the dot product, cross product, and how to analyze different types of questions in vector analysis. And a lot of this is going to stem from Calculus 3. So if you want to, make sure for the FE exam at least, make sure have a basic understanding about Calculus 3. You don't have to have like the super in-depth knowledge, but it is good to, go back and refresh these kinds of ideas. For the first one here, we use the dot product. It says find the dot product between these two vectors. And one thing we have to notice is the difference between dot product and cross product. A dot product will result in a scalar value. A cross product will result in a vector value. So scalar value will have no direction, it's just the magnitude. So here, when we do the dot product between A and B, we denote it by A dot B. This is going to be equal to I hat plus 2J hat minus K hat times 4I hat minus J hat plus 3K hat. Now, these I, J, and K hats, they are your unit vectors, or the direction that these magnitudes are going in. For dot product, we are going to multiply the like unit vectors, meaning I will be multiplied to I, J's will be multiplied to J's, and finally K's will be multiplied to K's. You do not mix them. So going here, we have I times 4I. Well, a unit vector times or dotted product with the unit vector is 1. So what this is going to become is 4. Then what you have is you have a plus 2J times minus J hat, or negative 2. Then you finally have the K hats, minus 1 K hat, or minus K hat, times positive 3 K hat. And what this is going to become is this is going to become minus 3. Okay? So 4 minus 2, 4 plus negative 2 is 2. 2 plus a negative 3 is negative 1. So that's going to be our dot product. And remember, if you get an answer that is a scalar value for a dot product, most of the time you're going to be correct. If you get a vector for a dot product, you know for sure you've done something wrong. Okay, so the next question here is, which of the following is a unit vector perpendicular to the plane determined by these two vectors? So the first idea or concept we need to know and know how to understand is the perpendicular kind of concept between two vectors. In Calculus 3, of course, we're in 3D planes, and we know, say you have a plane, you have some sort of plane like this, right? And it's saying perpendicular. Well, what is perpendicular to a plane? Perpendicular to a plane is something like this, where we have a normal vector that is perpendicular to this plane. So we have this plane that's defined on the 3D plane, the XYZ plane here, and we have a normal vector. Okay, how do we get a perpendicular vector? Well, what we do is we initialize two separate vectors, A and B, on said plane we'll call P, on plane P, and we take the cross product between the two, and it will result in the normal vector in. So to get the cross product, we need to do A cross B. This will give us, we'll call this vector the C vector, right? We'll just say C, just to go in order ABC, right? Okay, so we're trying to get C vector because we're asked to find the unit vector perpendicular to these two vectors. Now, how do we find a unit vector? Well, this unit vector denoted by this kind of C subscript U is equal to the C vector that we get from the perpendicular, taking the cross product between A and B, and dividing it by the norm or magnitude of our resulting perpendicular vector. So first thing we do, we take the cross product between a and b. This is going to be equal to, we do I, j, and k hat, and we have 2, 4, 0, because we have 2i plus 4j in the a vector. Now for the b vector, we have 1j or 1i plus 1j minus 1k. Okay, so now we do our quick cross product. What I do always is cover up the first one, the first column, and now you take 4 times -1, which is -4, minus 0 times 1, and I'll do this in green actually, which is 0. Okay, minus j hat. Always do a minus j hat. You cover this middle one, cover the second column, and multiply 2 times a -1, which is -2, minus 0 times 1, which is 0. Finally, we do a plus k hat, which is going to end up being, cover up this k column, and it's 2 times 1, which is 2, minus 4 times 1, which is 4. Okay, and now, remember, cross products result in a vector. We have to keep our unit vectors here. So it is I hat, -4 minus 0 is -4, minus j hat, -2 minus 0 is -2, plus k hat, 2 minus 4 is a -2. And what we're going to get is a minus 4i hat plus 2j hat minus 2k hat. So that is our vector C. That is our perpendicular vector to the plane AB, or plane P. Okay, so now we have to find the norm of our C vector, which is going to be the component squared and added up, and then the square root. Okay, so this should be equal to 16 plus 2 plus 2, 16 plus 4 plus 4, 24. This becomes 4 and 6, which is equal to 2 square root 6. So now what we do is we can do 2 over square root of 6 times, oh, sorry, not 2 square root of 6, 1 over 2 square root of 6. And then minus 4i hat plus 2j hat, and I'll move the rest of this over. Let's put that up here. Minus 2k hat. Okay, what we're going to do is we're going to come up here now. All of these in the vector can be, you can take a 2 out, right? So what you get here is a 2. We can replace this with a 2, replace this with a 1, replace this with a 1. So what we get now is these cancel. We get 1 over 1 square root of 6 times minus 2i hat plus j hat minus k hat. We notice this is the same as that answer. So this will be our answer. All I did at the end was simplify and get rid of some common values in the numerator and denominator. Hopefully that made sense. And again, just to go over the kind of the steps for this, if we want to find something that's perpendicular, we take the cross product. And if it ever asks you to find if something is perpendicular, you take the dot product. And if the dot product between those two vectors is 0, you have a perpendicular. The angle will be 90, and the vectors will be perpendicular to each other. For this last problem, we need to know the acute angle between these two vectors, vector A and vector B, both based at the origin. Okay, so that's good to know. But the big part here is we want to find the angle between them, and the equation for this is theta is equal to cosine inverse of A dot B divided by the norms multiplied. So A, of course, A dot B, we're going to find out is what? It's a scalar value. So what we have here is 3i plus 2j plus k times 2i plus 3j plus 2k. Okay, so again, we take the components, multiply each other. So 6 plus 2, we do this. 3 times 2 is 6. 2 times 3 is 6. 1 times 2 is 2. So 6 plus 6 is 12, plus 2 is 14. That's going to be the numerator. Cosine inverse 14 divided by, now the norm of A is equal to, well, what is A? A is 3, oh, it's right here, okay. So we have 3 squared plus 2 squared plus 1 squared. And then for B, we have the square root of 2 squared plus 3 squared plus 2 squared. Okay, square root of 9 plus 4 plus 1 is square root of 14. This next one is the square root of 4 plus 9 plus 4. 8 plus 9, 17. Okay, so the denominator will be square root of 14 times square root of 17. And for this here, we're pretty much done now. We just plug this into our calculator. If I can find mine. This should be in degrees, by the way, so make sure when you plug this into your calculator, you put this in degrees. And what I end up getting here is about an angle of 24.84 degrees. Or not 8 degrees. Oh no, yeah, degrees, sorry. So we're going to get an answer in degrees. You can have this in radians, I believe. Yeah, right, it wouldn't make any sense. So you could say this is equal to this, or it's about 0.434 radians. Okay, so that's for this video. We want to find the angle between, we want to find the perpendicular unit vector, and we want to find the dot product. So hopefully this was okay. If y'all need to ask questions, just you can ask them. And yeah, all right, thanks.